at rest. Like I gave you the example of when you have a ball, or if you place a book on a table, so that book is supposed to be there on the table unless anyone picks it up from there. Till anyone picks it up from there, you will find the object over there on the table only. So this illustrates here the law of inertia, and it tells us the inertia, the tendency of the objects to remain in their state of rest. Okay.
Yes, sir.
So we had seen different tendencies. Like if an object is moving, so it has the tendency of in motion.
Yes, sir.
So in the previous chapter, we had seen what is motion, how we describe motion. But in this chapter, we will see here in this chapter, we will see the laws of motion. That means the conditions under which there will be a motion. What will be the different types of motion? So that we will be looking here in this chapter. Okay. So in this chapter, we'll see the cause of motion. What is the cause of motion? What are the different types of motion? Under what circumstances or what conditions we can bring about any change in the state of motion. So here we discussed about the inertia. Can anyone tell me what is inertia?
Sir, the tendency of a body to resist any change in the state of rest or of a state of motion, motion on a straight line.
Okay. So the tendency of a body
To resist any change in resistance of a body, yes, sir. To any change in state of rest or of uniform motion in a object in a straight line, sir.
Okay. The tendency of a body to resist any change in
Any
the
change in
state
the
of
state
rest
of rest in a straight line.
or of uniform motion in a straight line.
Straight line, yes, sir.
Okay. So we had observed this tendency with different objects, which we called as inertia. For example, I discussed with the tendency of rest, so which we call as
Sir,
the inertia.
you told us when we
Yes.
suddenly accelerate, there's a jerky movement, right?
Yeah.
When the
So
object is
there
like,
will be a jerking movement that is due. Yes.
sir, you told whenever an
Yes.
object
Continue.
is rest, and we suddenly accelerate,
Hmm.
the jerky movement will cause that
Hmm.
cause us to tilt backwards due to the inertia.
Yeah.
Listen.
Okay. So here we discuss about the different types of inertia. The very first type of inertia is the inertia of rest. Inertia of rest, it simply means the tendency of a body to remain in the state of rest if it is in the state of rest. So if an object is at the state of rest, so it will try to remain in the state of rest only. So that we call as the inertia of rest. So an object in rest tends to remain in rest. Okay. So there is an opposition. If you want to bring that object in motion, if you want to uh, speed up, if you want to make that object move, so obviously there is something that will try to oppose the state of the change, that will try to oppose your efforts. Okay. So can anyone guess how can we measure the inertia? Yes, can anyone tell how can we measure the inertia? See, inertia depends on the mass of an object. Okay,
Sir,
a very
force is
important
equal
topic here that,
to MA.
yeah, we'll be coming to that. Just understand this. When we discuss about F equals to MA, okay. See, the problem is that we want to crack IIT-JEE and we jump. If you jump, even if you leave a single topic, okay, I'll give you certain examples of this. Okay. See, what my examples that will be there, you will be surprised to note that. Yes, this happens like this. Okay. So try to understand where you are. Okay, let's see, we will see maximum examples here. So, and this is very clear now. Everyone sees that, yes, it's all clear. Now we have understood that an object in rest tends to remain in rest. So, this is applicable to all the objects. If it is in rest, so what is that that is opposing the object? Can anyone tell what is opposing the rest? If you want to bring it in motion, so what is that factor that is opposing it?
Sir, inertia.
It's the mass of the object. It is the mass of the object that is opposing its change. The heavier the object, it is more difficult for you to bring it in the state of motion.
Sir, then if we want to bring it in motion, we have to just overcome its mass.
Yeah, you have to overcome its mass. That is, a mass is the factor that is opposing its motion. Okay, so inertia of rest, it depends on the mass of the object. Heavier the object, greater will be its inertia of rest. Okay, if you have a heavy object, okay, just think for a situation. You have a car, a motorcycle, and a cycle, all of them standing. They all are in neutral position. And if you try to push them, so which one is easier to bring in motion?
So the cycle,
The cycle is the easier one. So we say that there is a lesser resistance in cycle, a greater resistance in a bike, and still greater resistance in a car,
yes, sir.
and a still greater resistance in a truck. Okay,
Yes,
so
sir.
we observed here that the inertia of rest, obviously, it can be measured. Inertia, see, here in physics, we will be discussing only about the physical quantities. That means the quantities which can be measured. Okay, so inertia can be measured, and inertia of rest, it depends on the mass of the object. Yes, Rohit? Rohit?
So nothing, my doubt got cleared, sir.
Okay, so this was your inertia of rest. Now we apply this inertia of rest. That means any object which is in rest, it has the tendency to be in the rest. It doesn't want to move. So let us try to apply this to various situations. Okay. Suppose you have this is your surface. This is your surface, and on this surface, I have provided some wheels. Let's say these are wheels, and these wheels support a plane over here. Okay, these wheels, they support another surface, and on this surface you put some other object. Let's say we put here a ball. Now see what will happen. What I'm telling you and what will happen. Suppose this is your surface S1 and this is the second surface S2. This surface is not movable. You are standing over here on this surface S1 and you try to push this. Okay, you try to pull this surface. Let's try to pull this surface. Okay, so what this person will observe, if he tries to pull this surface, so what will happen to this ball? Will it move towards left? Will it remain stationary, or will it move towards right?
So it moves
That's
towards
right.
left.
The ball will move towards left,
Yes, sir, this
but
side.
but with respect to what? What will happen with respect to the surface S2, and what will happen with respect to the surface S1?
Sir, the surface S2
Surface
will.
is frictionless. Surface is frictionless.
Yes, sir.
This surface S2 is frictionless. So what will happen? And this man pulls this surface S2. He pulls this surface S2 like this. So what will happen? With respect to this surface S2, I will observe this ball A to be moving towards left, right? As the surface S2 itself moves towards the right. The surface S2 moves towards the right. So it will seem to me that the object A is moving towards the left. But with respect to the surface S1, since the surface S1 is stationary, so with respect to the surface S1, the ball will remain at the same position. This ball will remain at the same position here. If this is the origin, let's say I mark this place to be the origin. So the ball will remain at origin. It is only the surface S2 which will move. Are you getting?
Yes.
This is the inertia of rest. The tendency of this ball is to remain in the state of rest. So it will remain in the state of rest. It won't move anywhere from the origin O. However, since the surface S2 is moving, so it will appear to me that it is moving towards left on the surface S2. But
Sir, can
with
you
respect,
explain once again?
yeah,
Sir, once can you explain again?
okay. So this seems to be a little bit complicated. Let me give you another example. Let's see another example now. And with that example, I think you will be able to get this situation also. So suppose if you have a bus that's moving and the surface of the bus is frictionless. Again, the surface of the bus is frictionless and inside the bus, I keep a ball. So here inside the bus on the surface, I have kept a ball. The bus is stationary and now the bus accelerates, it starts moving towards the right side. So to all the passengers who are sitting inside the bus, what will they observe? With respect to this floor, the bus will start moving in the this ball will start moving in the backward direction.
Yes, sir.
Yes, yes. So since the surface of the bus is frictionless, and when this surface starts moving backward, so due to the inertia of rest, this ball will try to remain in the state of rest. So it will try to remain at the same position with respect to the ground. And hence, when the bus moves forward, the ball will seem to move backward, but with respect to the ground, it will remain at the same position. So after some time, you will observe that bus has moved like this, whereas if there is a hole, so ball will come out and it will drop at the same place. There will not be any motion in this ball. So this is because of the inertia of rest. The same thing is happening here also. The same thing. Again, with respect to the surface S2, the ball will appear to move backward. But with respect to an observer over here, with respect to the ground, the ball will remain at the same position.
Sir, this is
Got it?
inertia of rest.
Yeah, this is due to the inertia of rest. So up to now, you might have heard about these examples. Like suppose you take a glass and on this glass you keep a cardboard. You must have heard of this example. And on this cardboard, you place a coin. So here I place a coin on this cardboard. Now if I flick this cardboard from here, I flick this cardboard from here. So cardboard will go away, but the coin will remain in the state of rest. So the coin will fall in the glass. It won't move anywhere. It will fall in the glass. Got it? Yes, it is because the tendency of the coin is to remain in the state of rest. The tendency of the coin is not to move. It is to remain in the state of rest. So this is due to this reason that coin remains in the state of rest. It doesn't move forward. Okay. So shall I give you some more examples for this?
Yes, sir.
Yeah. So suppose beating a blanket. Let's say we take a blanket here and we try to beat that blanket. So we have taken a blanket. This is a blanket and we try to beat this blanket with something, with a stick. So let's take up any stick and try to beat this. So with a stick, we are beating this blanket. So do we observe dust particles coming out of the blanket? If you beat a blanket with a stick, so we observe here that dust particles come out of the blanket. Can anyone explain the reason why the dust particles come out of the blanket? Yes. Can anyone explain why the dust particles come out of the blanket? The reason being that when we hit this blanket, the blanket comes in the state of motion, but the dust particles which are there, whatever dust particles are there, so those dust particles, they remain in their state of rest. The tendency of the dust particles is to remain in the state of rest. So when we beat it, the blanket moves backward. The blanket moves backward, and the dirt particles, they remain in their state of rest. So as a result, the dust particles are separated from the blanket due to the inertia of rest. Due to their tendency to remain in the state of rest, they did not travel along the blanket. They remained in their state of rest only. Got this example?
Yes, sir.
Yes. Yeah. All of you be active. I should see everyone active, or you should keep your camera on. Within 2 minutes, I will start informing in the group if your camera is not on. Either you inform in the group that yes, my camera will not be on or whatever, or you keep your camera on, or I shall inform in the group that your camera is off. That doesn't look good if I inform in the group. Whatever arrangements you have to make it, and then keep your cameras on. Rohit, if anyone has a specific problem or any problem, do inform before the class in the help and support group, right? And let's have a good class. So here, everyone has understood about the beating of the blanket. What about falling of the fruits during a can anyone explain the falling of fruits during a storm?
Sir, falling of fruits during a
Storm. What happens during a storm? During a storm, we have fast moving winds which starts blowing. So due to that fast moving winds, the branches start moving. When the
yes.
branches start moving, the fruits which are attached to the branches with
Where is it?
with
Is it because the wind is applying more force on the tree branches?
the wind is applying the same force everywhere, but it's the
Okay.
branches which are moving the most. Okay, when the branches start moving, the fruits experience a jerk because of the inertia of rest. Fruits appear or fruits maintain their tendency of the rest, whereas the branches move to and fro. Are you getting? So due to the inertia of rest, the branches start moving, fruits remain in their state of rest. As a result, the fruits experience a jerk, and because of the jerk, again, the fruits fall off. Okay. And we also do the same thing uh, when we have to plug those fruits, so we can shake the branches. If you shake the branches of the blackberries, if you shake the branches of the mango trees, so you observe that fruit starts falling.
Sir,
Yes.
when the branches are moving for a long time, wouldn't their inertia of rest change to inertia of motion? Sir, wouldn't their state of motion be, wouldn't their rest be changing to motion?
Yeah, branches are changing. Branches are stiff. Also, branches are bending. Branches can bend. Okay, so they have their inertia of motion. I'm talking of the fruits. The fruits are having the inertia of rest. They are
Sir,
not moving, but the branches are moving.
sir, so to remain in inertia of
Branches are moving. Fruits.
Sir,
Yes,
is it because the branch is in motion and the fruits are at rest?
yes, the fruits are at rest and if the branches start moving, that is what happens during the storm.
Yes, sir. Sir, I
Yeah,
had
the
seen
branch.
a similar example in the textbook while going through the chapter.
Okay.
Sir, it was that
So
carrom board one where the striker hits if you strike the striker with, like if you strike the striker quickly, the bottom coin moves, but the
mm,
coins on top don't move.
yes. So this is also you can see if you keep a heap of if you keep those coins like this, a pile of coins, those what
Yes,
tokens
sir.
which are there in the carom board, if you keep your tokens like this, you can try it out. And with your striker, you hit it hard. When you hit it fast, so the bottom token will move and the remaining tokens will remain in the state of rest. Okay.
Sir, this is
So this
because
is
the
again,
top ones are at rest and the others are in motion, right?
yeah, all of them are initially in the state of rest, but we are applying the force only on the bottom one. We are not applying the force on all.
Sir, but if we hit the striker hard, won't all of them fall down?
Uh, See, due to the friction between the different tokens, okay, of course, there is a friction between all the tokens. Okay, so due to the friction between the tokens, they will tend to move. Now it depends how much is the force of friction between them. If the force of friction between them is very less, so you can strike them and none of them will fall.
Okay, sir.
Okay, so got this inertia of rest.
Yes, sir.
An object in motion will remain in the state of motion. It will oppose any change. It will oppose any change that is being brought about by any external forces. Okay. So it is going to oppose. If you are trying to bring it in the motion, it is going to oppose. Okay.
Sir,
For example,
sir, is external force seen in these examples?
yeah, external force. Whenever I'm saying force, it generally means external force only.
Yes, sir.
Okay. We are not talking of the internal forces. Anyone having any other doubt?
No, sir.
Okay, so we have seen various examples now. Now let's see the inertia of motion. The similar case with the inertia of motion. The inertia of motion means if an object is in the state of motion, so it continues to be in the state of motion. Now I will give you various examples to understand this. And I will ask you certain questions, you will get puzzled from the inertia of motion. I know most of you have understood about the inertia of motion. Let's see if you can apply it. So inertia of motion, it states that if an object is in the state of motion, so it tends to remain in the state of motion. It doesn't want to change its state. Okay. So inertia of motion, if an object is in the state of motion, so it will tend to be in the state of motion only. It won't it won't try to change its state. It won't try to become in the state of rest. For example, suppose if a bus or a train is moving and all of a sudden you jump out of the train.
Yes, sir.
So eventually what will happen?
Sir, we
You'll,
tra-
you will
sir, we
fall off.
travel to
Yes,
plan.
sir.
Yeah. So in which direction will you fall? In the forward direction or in the backward direction?
Sir, in
Forward
back
direction.
backwards.
See. So if you jump out of this, let's say your train or bus, whatever is this, it's moving along this line. Let's say it is moving like this.
Yes, sir.
It's moving towards the right. And if you jump out of it, if you jump from here, so
Sir, we'll jump out. We'll go to the left side, right?
yeah, in whatever direction you jump out of it, if you jump out of this, so since you are sitting over here in the train and you were traveling along the train was making you move along with it. You are moving along with the train.
Sir, so
Okay.
we fall in the forward direction.
Yes. So suppose if the train was moving with a speed of 40 kilometer per hour So the tendency of your body is still to move with the speed of 40 kilometer per hour. So if
Sir,
you jump out, yes,
sir,
yes,
will we jump forwards or back? Will we jump forward or backwards
you
in
will
this?
fall forward.
Okay,
You
sir.
will fall forward. Okay. See, if you are traveling with the train, you are traveling with 40 kilometer per hour. That is the speed of the train. And if you jump out of it, so your tendency will be to travel in the forward direction. Your body still has the tendency to travel in the forward direction. So even if you jump out of it, your feet will fall here, and the tendency of your body will be to move forward, and hence you will fall in the forward direction.
That is
Got
the
everyone?
reason
Yes,
we
sir.
travel with the train for a distance and then stop.
Yeah, if you jump out of the train and keep running with the speed of 40 kilometer per hour, you should be running with the same speed with which the train was traveling, and then slowly and slowly you can decrease your speed and stop. That is possible. But certainly it is not possible for you to travel at a speed of 40 kilometer per hour. Okay, we can't run at a speed of 40 kilometer per hour.
Yes, sir.
Okay, if somehow you are able to run, so you will not fall off.
Okay, sir.
Okay, anyone having any doubt?
No, sir.
No,
Okay,
sir.
now see my question. Again, a similar question, and let's see if you can answer. And if you have any doubt, you can assume uh, a car. Suppose a car moving at some speed of 100 or 90 kilometer per hour, and suddenly the car collides with some other object. So if the car collides, so what will happen to the passengers? Will
The
they move?
passenger, sir, the
Yes,
passengers will fall forwards out of the car, sir.
Yes, sir.
yes. The passengers will fall forward, and that is why in car we have the provision of seat belts. Yeah. So seat belts are provided so that if there is sudden braking, so the passengers won't fall in the forward direction. It will stop them from falling. Also, you have airbags, which will
Sir, but
stop them.
even if the car collides, won't we go forward? Like, won't we move a bit forward
Yes,
because
your
of the
tendency will
inertia?
be to move forward. You will move forward. Yes, you will move forward. But that those seat belts, they will support you.
Yes, sir.
Yes.
Sir,
Now
the
let
air,
me, yeah, so that system is everywhere. You have to. Now let me ask my question now, and let's see if you can answer. All of you listen it carefully. Okay. So can I expect everyone has traveled through a bus or train?
yes, sir.
Everyone? Okay.
Yes, sir.
Now, okay, has it happened any time that you have taken a cold drink or a chips or anything and thrown your wrapper or whatever outside the bus with the window when the bus is moving?
Yes,
This is
sir.
common observation to everyone,
Yes,
right?
sir.
So, okay, my question is, if I'm throwing my ball or whatever, if I throw my ball or whatever out of this window, so in which direction will it move? Should it move in the forward direction or in the backward direction, or will it fall at the same place?
Sir, it will fall at the same place.
Yes,
Sir,
anyone?
it will go forward.
Think of it.
Sir, it
Jitendra,
will
are you
go
there?
backward.
Yes, sir.
Jitendra, are you there?
Sir, it will go backwards.
Yeah. See, what is our observation? Our observation says that it goes in the backward direction, right? Okay, but the physics says, what does physics say?
Falls forward.
Falls forward. The
Sir,
physics
physics
says,
Same
says
place, sir.
that.
Same place.
okay, so by what your logic you are saying same place? Your
Sir,
common
uh,
observations. Hmm.
sir, because if we throw it out, it will land in the
Hmm.
same place. But when wind is there, it may move forward or backward, right?
Okay, okay, okay. See. Now the actual answer is here. When you throw anything, it will fall in the forward direction like this. it will fall in the forward direction. Okay. Now, I'll explain you what your observation tells. As you have observed, so you observe the object to be falling backward. You never observe the object to be falling forward. Okay. You can observe it to be falling forward in any normal situation. You can observe it. But the point is that your friend should be sitting in the bus and you should be standing here on the ground. If you are standing here on the ground, observing your friend throwing these wrappers or whatever outside of the bus, so you will observe this packet to be moving like this. You will observe this ball or whatever is there, you will observe this moving like this. Okay. But when you observe, you will observe it to be going backward. The reason is that when you throw it, just when you release it, the air opposes its motion and hence its speed decreases. Its speed in the forward direction decreases. So your speed being higher with the bus, you travel forward, whereas your ball lags backward. So it seems to you that the ball is going backward, or whatever substance you are throwing, it seems to you that it is going backward because your speed is greater and the speed of the ball is slower. However, it is also going the same way, but it will seem to you that it's going slower. So it will seem to you that it's falling backward. If you observe the same scene from here, from the ground, so you will observe this to be going like this.
Sir, so the direction of it depends on where the observer is.
Yes. See, remember, we had seen in the first chapter, we had stated that motion is a relative term. It depends on our point of observation, right? Rohit, Mohammad Rayan,
Sir,
Yes, sir.
Sir, I'm
yes.
listening, sir.
sir, can you explain once again? I'm still confused.
Okay. So if you are still confused, have you ever tried while sitting in a bus or a train, ever tried to throw a ball upward and catch it again?
Yes, sir, like once.
Yeah. So what happened? Were you able to catch the ball?
No, sir, it fell down.
It fell down. Okay. Have you seen any flies or anything which is flying in the train? Housefly flying in a train?
Yes, sir.
Yes. So your train is moving with a speed of 120 kilometer per hour. Can a housefly move with a speed of 120 kilometer per hour?
No, sir.
No. Then how it is possible that a fly jumps out of one seat and it moves to the next seat? How it is possible?
Sir, is it because
Yes.
sir, is it because of the inertia of motion?
Yes, due to the inertia of motion, when the fly is inside the train, it is traveling with the speed of train. It is already traveling with a speed of 120 kilometer per hour. Okay. So when it jumps off one seat, it has a speed of 120 kilometer per hour without any effort. Okay. It is traveling with a speed of 120 kilometer per hour without any effort. Okay.
Okay, sir.
Then with its effort, whatever its speed is added on, gives it the desirable speed to jump from one seat to the other. So if you are throwing the ball, see again observe, if you are here, you throw the ball in the upward direction in the train. So the ball will move up. But remember, the ball is traveling along with the train. Even if the train, even if you leave the ball in air, ball has the speed of 120 kilometer per hour. It has the inertia of motion. It has the tendency to be in the state of motion. So this ball will travel in the forward direction along with you. So to you, it will appear that ball is going up and falling down. But to a passenger who is outside, will observe the same ball to be moving something like this. It's moving something like this. To a passenger who is outside, he will observe the ball to be moving like this. But you will observe this ball just to be moving up and down. The reason being, you are traveling along the ball is traveling along with you. If you are here, so the ball is in your hand. If you are here, the ball will be here. If you are here, the ball will be here. If you are here, the ball will be here. So the ball is traveling the horizontal distance along with the vertical distance. Got it? So ball already has a speed of 120 kilometer per hour. It will fall back to your hand only. Okay. If you are in an aeroplane, so in an aeroplane, if you just take a ball and throw it upward and try to catch it, you will be able to catch it up. Got it?
Yes, sir.
Understood the inertia of motion? So every object which is in the state of motion, it continues to be in the state of motion, okay, unless there is an applied external force. So the tendency of an object to remain in the state of motion, if it is in the state of motion, is called inertia. Got it? And inertia of motion, it depends on two factors. It depends on mass, and there is another term which we will be discussing. Okay, so that we'll be discussing later. But this, it also depends on mass. There is another factor along with mass. We'll be discussing that later.
Sir,
Yes.
sir, at times when we apply some external forces applied on us, our body also resists. So it then we are also then that is also inertia only.
Yeah, that is also inertia. If your body, see, it's not that you are trying to, you are mentally trying to stop there. So that is not inertia of rest. Inertia of rest is your body will oppose its motion. If someone is pushing you, okay, so or if suppose if you are standing, so your body will try to oppose the motion.
Okay, sir.
Okay. So you might have seen certain YouTube stories or somewhere like our Earth is rotating with a very high speed, right? Our Earth rotates with a very high speed. So if all of a sudden Earth stops rotating, so what will happen?
Sir, we continue move in what direction the Earth is rotating.
Yeah, we will continue to move and we will fly off in air. All of us will fly off in air. If Earth all of a sudden the Earth stops, so we will, due to the inertia of motion, we will fly off in air. Got it? Okay. So everyone has understood this?
Yes, sir.
Yes, sir.
Anyone having any doubt?
No, sir.
Okay.
No,
Now
sir.
I'm giving you one more question. Let us try to, let's see if anyone can answer. So this is again, listen the question carefully. Okay. I think we shall discuss that in the next class. Okay. Care of only with the time. I'm giving you the question. You can think of it at your home. What will happen? Okay. Just think of it at your home. I have a hot air balloon. Okay. And this hot air balloon is rising upward. There are some people sitting in this hot air balloon. Okay. I'm observing from the ground. Here I'm stationary on the ground. The balloon is moving upward with a speed of 5 meter per second. Okay. At a certain height, let's say at a height of about 20 meter, some food packet is dropped from this. A food packet is dropped from this hot air balloon. So can you explain me the trajectory or the path which this ball food packet will follow? What should happen? I am observing from here. So what should happen to this packet? When I observe, so to me, will the food packet appear to fall downward, or will the food packet appear to move upward, or will it appear like the food packet first moving upward and then falling down? See, the people here, they are not throwing it. They are just leaving the packet outside. Okay. So this is your question. Think of this. We will discuss the answer in the next class. Bye, everyone.
Bye, sir.
Bye.